aluminum foil, and the K value is given, which is 210 megapascals, and the index N equals to 0.16 together, as discussed in the class. The final thickness of the sheet is 25 microns. So you are using a roller with a diameter of 10. So the diameter of this roller, if this is 10, then the radius would be 5 millimeters. The width, this width is 3 meter wide, and the coefficient of friction is 0.12. Each roller has a motor power 25 kilowatts. So let's do the sum. Apply this formula for maximum change in the height. You can use this formula, which has been described in our class earlier. So can you help your professor if you are given the maximum change in the height, which is h, I will say h beginning. This is my h beginning, hb minus h final, mu square r. Mu is the coefficient of friction between the roller and the workpiece or the sheet of metal. It is 0.12. Okay, 0.12 square, and the radius of the roller is 5. So can you do the math? Let me know what do you get from here. Do you get 72 microns or micrometer? Agreed? 0.12 square times 5, which is 0.072 millimeter or 72 micrometer, because 1 meter has 1000 millimeter. Okay. For one sheet, the initial thickness, the final thickness is 25 microns of each sheet. If you closely take a look, each sheet, so you can imagine these are the two sheets being rolled together. This is sheet 1, this is sheet 2. So for each sheet, HB1 would be equal to final thickness plus 72 divided by 2. So this is how much? 61 microns. So initial thickness of each sheet would be 61 micron. This is a maximum initial sheet thickness. And for the force on the roller using the results from A, how much force you have to find out. So let's use the formula here. P average. P average, if I go back over here to this, P average. This is the formula. If you know the pressure applied by each roller, you can multiply that pressure by the thickness. So area. Pressure equals to force per unit area. And that means force equals to pressure times area under the roller. So if this is a roller, this is my case, okay? So this is my arc. This is the arc which is in contact with the sheet. So L, you already know, R times delta H. Times, if you go back to this width, which is equal to 3 meters. So this sheet is 3 meter wide times L. So the area would be L times W, and P would be this formula. So you just have to find out the unknowns, P average first. Let's do P average first. And Y flow equals to K epsilon to the power N over N plus 1. And strain equals to natural log initial height over final height. And let's do this calculation first. Initial height is 61 micron of each sheet divided by the 25, which is given in our problem. The final thickness is given. The height final thickness is given. So if we do the math here, it should be equal to 0.89. Do you verify that? And once you verify that, you can use this. I want to plug in this value here. K is the strength coefficient, which is 210 megapascals. So let me write down here 210 megapascals, 0.89 to the power 0.16, which is the index n, 1.16. And if you solve for this, do you get 178 megapascals? Yes. Okay, one student says yes, that's good. So we have found this average flow stress, but since it's a per unit depth, so we have to multiply by this factor for the von Mises criteria. It's the same criteria we use for forging analysis. So we have to multiply this by 1.15. So but let's find out whether we have to use this formula or no, because let me show you. This formula can be used when you have um, rollers, large rollers. So whether they are large rollers or small rollers, we have to find it out using a formula over here. Yes. Can you find out this one? I want to share with you, before you jump to the P average formula, I forgot that you have to check. You have to check whether these are the large rollers or small rollers for this one from this formula. And L equals to square root the radius of the roller times the change in length, change in the height. The radius of the roller is 5 um 5 millimeter. So let's convert it into meters. And delta H maximum is 72 microns. If you solve for this, you should get 6 into 10 to the power negative 4 meters. This is the arc length which I was talking about in contact with the roller, with the metal which is going through the roller piece. You see, that is the length, arc length, and that's how you calculate that one. And let's see whether H average, since we have two of these, initial thickness plus the final thickness, 61 plus 25, 86, divided by L. Point 144. This is micron. Sorry, you have to multiply by -6 because this is in microns. You understood that point? So since it is much smaller than 1, so these are the large rollers. So for large rollers, you will use the formula for the pressure is this one. So after you verify this formula is going to be used, then you can find out the pressure and then you multiply by area to find out the rolling force. So let's do this. We already have calculated Y average stress flow, which is 178 megapascal, 10 to the power 6, 1 plus point. What is the coefficient of friction? 0.12. Agreed. And the arc length is 6 into 10 to the power -4 meters. 6 into 10 to the power -4 meters divided by 2 times average height, 86 microns. You have to consider this for the two sheets. Now, this is my P average. And if you want to find out the force applied by each roller, you have to multiply by P average times the area in contact with the roller. And that is equal to the arc length of the roller with the contact with the metal times the width of the metal. As I mentioned earlier, this is the width inside the paper. So you have to multiply. So let me write it down here. I would write down again. You will open your calculators and help your professor finding the force. Six into 10 to the power negative 4 times the width 3 meter. L is that's correct. If you solve for this, force applied by each roller is 523 kilonewtons. Can you please verify the answer? You verify this. One student verifies, hopefully the others will also verify. And the C part says, C part is finding the speed of the, let me tell you, determine the maximum linear rolling speed using the result from A and B. So if I tell you, suppose this is speed, tangential speed, and if I give you, suppose I take this roller and speed is this one. This is my radius, and this is rolling like omega. Do you know V equals to R omega? And for the rotating bodies, if you are given power, can you write down power formula as torque times omega? And torque equals to force times the moment arm. Moment arm is the arc length, half of the arc length. Okay, now let's grab this formula and this information and use for our calculation. Torque, let's find out torque. And then from torque, you will find out omega. And omega, once it is found in radians per second, then you will use V equals to omega times R. Okay, let's do it together. Force 523 in 10 to the power 3. L is 6 in 10 to the power negative 4 divided by 2. It is 157 Newton meter. And from here, if I use this formula, omega equals to power divided by the torque. Power is 25 10 to the power 3 watts divided by 157. How much is that? You get 159 radians per second. And if you get 159, you will multiply 159 by the radius of the roller, which is 5 millimeter or 5 into the power negative 3 in meters. And you get this tangential speed of roller is 0.8 meters per second. Please note it down. Have you understood this problem? You want me to share this lecture PDF notes with you? I will share it with you. Noah, you have some question? Yes, this is the maximum change in the height. So for each sheet, we have to divide by 2. This is for per sheet. Exactly. That's why I made 2 sheets, S1 and S2. Okay, let's do the next question here. So I want to show you. Maybe this one. For hot rolling, now since we are hot rolling, we will have a different formula for hot rolling, which is given. I try to give most of the formula in the exam, but you are allowed to bring one formula sheet for your quiz. I know there are many formula. So if I were you, while I'm practicing the problem, I will write down the formula sheet to memorize where I use this formula, where I use this formula. That will help you. But you have to practice tonight and tomorrow. You have 2 days. This day is almost gone. Tomorrow, you can spend 6 hours at least. You are hot rolling a metal slab, and you see this is the formula. Hot rolling formula. Okay, now let's first of all find out whether it's a large friction. When it is a large friction, you have a large roller because arc length, if it is very, very big, it has a larger contact. When larger contact means large friction, smaller contact means small friction. When small friction, you will use this formula. You see this, and maximum change in the height is this formula. So we have all the formula available for us to solve this problem. You understand this problem? Okay. You are hot rolling a metal slab. The rollers have a diameter of 300 millimeter. So if the roller, if they have the diameter, okay. Now, if this is the diameter, let me tell you. And what is the radius? So you will tell me, Professor, radius equals to diameter divided by 2. Usually we are concerned about the radius. Most of the, like over here, we are using radius, and then we will use it over other formula. So it is 300 divided by 2, 150 millimeter. The initial thickness of the slab. Initial thickness is given. This is final thickness. 100 millimeter initial width. This is my width. $3. The material has the coefficient C, strength coefficient 50 megapascals, and the index M equals to 0.1. Coefficient of friction is 0.25, and the power is given 750 kilowatts. And power for the roller is torque times omega, and torque equals to, it is given over here, torque equals to force times half of the arc length. This is the arc length which is in contact with the roller. So determine the linear speed and the maximum possible reduction in the thickness with one set of roller. So you have to find out VR. So delta H maximum. Can we use this formula? Mu square times R. Mu equals to 0.25. $150. Is it 9.4 millimeter? Can you verify? That's the maximum reduction in the thickness of the slab. Yes, you got the same answer. Delta H maximum. So H beginning minus H final. So H final would be equal to H beginning minus delta H maximum 100 minus 100 minus 9.4. This is 90.6. Final thickness. Do you understand that? Okay, the next part says what is the rolling speed? And I mentioned earlier the rolling speed can be found V equals to R omega, this formula. R times omega. Omega can be found torque omega. I'm going backward. And just to show you that how do you, it's good. If you start writing the formula, I'll be happy to see in the worksheet solution because I want you to apply the knowledge, whatever knowledge you have on the solution worksheet. And then power equals torque, force. Now for P average, you have two formula. Either when the friction is large, you will use this formula. When friction is small, you will use this form. For small rollers, friction is small. For large rollers, friction is large. But let's decide whether delta H average over L is greater than 1. So check. Initial thickness plus final thickness divided by 2 is the age average. Divided by L. And L I haven't calculated, but we can calculate L. Maximum. Okay, guys. So what is R? Radius of the roller is 150 millimeter. And the maximum thickness reduction is 9.4 millimeter. So you get 37.6 the arc length inside the metal slab. You get the same answer. Can you verify? That's good. You did a good job. Now look, I can write down here 37.6. And after doing this, I get 2.53, which is greater than 1. And you see, if it is greater than 1, like over here, you will use small roller formula. P average, look, this is even simpler than the large roller. The formula for large roller is little more complex than the small roller. So I'm gonna find out P average, which is 1.15. So let me write down for small rollers, P average equal to 1.15 average stress, average flow stress. And average flow stress, you already know, we did that. Oh, this is different case. This is average flow stress. This is the formula. Look, C times epsilon rate is not that K epsilon N. Make sure this is hot forging above the half of the melting point of the metal. So let's change this technique. So Y average flow for hot rolling. I would say hot rolling. The previous question was for the cold rolling, where the hot rolling is used when the temperature of the material is greater than half of the melting point of the metal, and YF is C epsilon dot average epsilon dot. And you will ask me, Professor, what is the formula for the rate of the strain rate? I will say strain rate. What is the formula? It is given. Look, this is the formula. So strain rate equals to average strain divided by the time. And that is equal to V roller divided by L, H initial, H final. So here there is little bit different because the V roller is not in this case, it is different. So for average, for the cold rolling, you will use this technique. For the hot rolling, you will find out V roller from this formula. I'm sorry, I explained this one for the cold rollings, but this is for the hot rolling. So you will use this formula to find out the roller speed. And let's do the math here. What is my ln hb, initial thickness of the metal divided by final thickness? So let's do this math here. Y flow, I can write it down here. P average 1.15 and do we have this? Yes, 750 kilowatts is given. C is how much? C is 50 megapascal. Yes, C is 50 megapascal. Epsilon, average epsilon strain rate equals to VR over the arc length 37.6. I can convert it into meters. And it is 0.1. Agreed? Now hold to the power m. Power index equals to m, which is 0.1. So, okay. Now, force of the roller equals to P average times the length, arc length times the width. Arc length in our case equals 37.6. So can I write down like this? P average 37.6 into the power -3 into the width, which is 3 meters. If you take a look, the data says it is 3 meter wide. This metal slab is 3 meter wide. So this will give you the force. And then once you know the force, you know the torque equals to force times L by 2. You can use this formula. Let's grab this and times L by 2. P average. So I'm gonna share with you this answer. So after you do this, then torque times omega equal to the power. And the power is given. How much is the power of the roller? Each roller has 750 kilowatts. So I can write down, let me write down, combine everything, putting all together. Let me share. It is 750 kilowatts equals to torque. Torque equals to Fr times L by 2. Fr equals to this one. So let me write down from here. So from here, like T equals to omega, omega is V over R. V over R is L by 2. Agreed? So now is everything is complete. So torque equals to Fr. Fr equals to P average times 37.6 10 to the power -3 times 3. This is my area, okay? Area under the roller. And that gives me the force times L by 2. L by 2 is 37.6 into the power -3 divided by 2. So this gives me a torque. You understand that? This is the torque. And times omega, VR over L by 2. Sorry, not L by 2, but R. Here there is little bit error. Can you fix this error? VR over R. Because V roller tangential speed of the roller is nothing but by r omega. I wrote down r, but now I'm fixing it. VR over r equals to omega. You see my point? Did I make the same mistake before? No, I did not. I wrote down r, not L by 2. You understood that mistake? So now, from here, everything is known except VR. And if you do the math here, VR equals to 0.83 meters per second. I give you some time to verify.